Hello, I'm Kirk Weiler, and this is Common Core Algebra 2 by eMath Instruction. Today, we're going to be doing Unit 11, Lesson number 9 on sinusoidal modeling. Now, sinusoidal modeling is just a fancy name for taking phenomenon that fit some kind of a sine or cosine curve and modeling them with sine and cosine equations. In other words, right, what we want to do is we want to somehow take curves like that and fit them to particular real-world scenarios and understand all the different parameters that go into the model. So let's take a moment to review what we've seen so far. All right, there's a bunch of different coefficients or parameters in sinusoidal models. There's your A, your B, and your C, right? A is the absolute value of A is the amplitude, C is the midline, B is known as the frequency, and P is the period, right? Now remember, the whole idea is that we've got some sinusoidal curve, a midline that splits it, we've got an amplitude, that's how much the curve rises and falls above the midline. Then we've actually got the midline, just how much is the average value above 0 or below 0. And then we've got that period, right? The horizontal distance that it takes for the curve to complete itself. Don't forget that the period doesn't show up in the equation. What shows up in the equation is actually the frequency. But the frequency and the period are related by this relationship B times P equals 2 pi. Okay? So keep that all in mind as we jump into the first applied exercise. All right, let's take a look. The tides. Tides are something that show up a lot in standardized assessments on this type of thing because they are very periodic in nature. It's really cool if you ever go to a tidal location on the ocean and you look at a tide chart, you'll see that, the tide's going up, the tide's coming down, etc. In this one, it says the tides in a particular bay can be modeled with an equation of the form d equals a times cosine b times t plus c, where t, that's the input, represents the number of hours, important, since high tide, so the number of hours since high tide, and d represents the depth of the water in the bay. All right, so the input is the number of hours since high tide, since the depth is as great as it's ever going to be, and d, the output, represents the depth of the water. The maximum depth of the water is 36 feet, and the minimum depth is 22 feet. High tide is hit every 12 hours. High tide is hit every 12 hours. Now, letter A says, on the axes, sketch a graph of this scenario for 2 full periods. Label the points on this curve that represent high and low tide. Now, you might say to yourself, wait a second, how can I sketch this? I don't have the equation. I can't put it into my calculator. But you can. All right, you can't put it into your calculator, but you can sketch it. Now, we know that at t equals 0, right, we're at high tide. We're at the greatest depth that we're going to be. We're at 36. And then it's going to get lower. It's got to get lower. I mean, it's at high tide. And then it's going to complete. Now, how long did it take that to complete? Well, it took 12 hours. All right, so here is the point 12, 36. Now, the low tide, of course, by symmetry, is going to happen after 6 hours. And that depth is 22 feet. So this point is at 6, 22. All right. Now it says 2 full periods. This is only 1 full period. So here's 2 full periods. What point is this? Well, that would be 12 hours later. That would be at 24, 36. And this would be at 6 hours after that. That would be at 18, 22. So there it is. There's our sketch. All right. Now, letter B says, determine the values of A, B, and C in the model. Verify your answers and sketch are correct on your calculator. Okay, we'll do that eventually. But first, let's figure out the values of A, B, and C. All right, you can do these in almost any order you want. But why don't you pause the video now and see if you can figure out any of those values. All right. Well, I hope based on previous work that you've done on homework, you'll be able to do it. Very often, I will figure out the midline value first. That's C. All right. And C will always be the average of the lowest value and the highest value. That's why we sometimes call it the average value. So that's going to be 58 divided by 2, and that gives me a midline value of 29. That's actually a Y value. All right. After that, I'll oftentimes find the amplitude. We talked about the fact that you can find the amplitude in many, many different ways. My preferred way of doing it is to actually find the distance between the max and the min and divide that by 2. So that's going to be 14 divided by 2, and the amplitude is going to be 7. All right. Finally, if we want to figure out the frequency, we first need to know the period. But the period of this curve, whoops, I just about put 24 hours down. That would be wrong. The period is actually only 12 hours. So we can now figure out the frequency by doing 12 times the frequency equals 2 pi. And the frequency is now 2 pi divided by 12. By the way, it's completely okay to leave the frequency that way. I kind of like it left that way. But you never know, you could have a problem that also says you have to put it in simplest form, which would be pi over 6. Now I'm kind of running out of room right here, but what I'd like to do is actually write out the equation now. So now the equation, actually I shouldn't do it in y. I could do it in y, it doesn't really matter. But my equation now is d equals 7 times the cosine. I think I'm going to leave it as 2 pi divided by 12 times t plus c. That's my equation. All right. And let's verify that. We're going to need the graphing calculator anyway for letter C, so let's verify our answer. Let's bring out the TI-84 Plus. All right. So let's go into y equals. Clear out anything you might have in there. All right, and let's put that in. We'll have to put it in with x's and y's, but whatever. Let's put in 7 cosine 2 times pi divided by 12 times t. Don't forget the t. Now close those parentheses. Now plus 29. By the way, I know that this can look like you're dividing by 12 times t, but order of operations means it's going to do 2 times pi, get an answer, divide by 12, get an answer, then multiply by t. So you should be fine. The only danger is if you have some kind of fraction command on, then if the t is sitting in the denominator, then the t is in the denominator. All right, well, let's set up our window. Before we do that, let's take a look at our mode. Hit the mode button. Make sure you're in radians. Now, I'm always in radians during this part of the unit because I know I'm doing trig graphing. But you never know. You never know if you're taking physics at the same time. Maybe you've put your calculator in degrees, and that'll completely throw you off. The graph won't even look vaguely the same. All right, but I'm in radians. Let's go into our window. Now, to set our window, I want to kind of make it look the way it looks here. So what I'm going to do is I'm going to set x minimum. Remember, my x is my inputs. It's my time. I'm going to set x minimum to be 0. And I'll set x maximum to be 24, just so I fit just those 2 periods in. Now, I could do y minimum as 22, but I think I'll keep y minimum at 0. Okay? And I think I'll put y maximum at 40. So I'm going to make that window a bit bigger than the one that I have sitting there, but that should be okay. All right. One thing that we've been doing a lot lately is we've been having the grid turned on. I don't think I want the grid on this one. All right. Before I do that, though, since I'm still in the window, what I think I'll do is I think maybe I'll just make my x scale into 6. That might be kind of nice to have like a little tick mark every 6 hours. So make my x scale 6 and I'll leave my y scale at 1. That's fine. It doesn't matter. But now what I'd like to do is I'd like to go into my format, and I'm actually going to turn my grid off. I don't want my grid on anymore. We've been doing a lot of graphing with the grid on, If it's currently on, I would suggest turning it off. It won't kill you if it's on, but there'll just be a lot of lines on the screen. All right. That's done. Let's hit graph. All right. It looks good. Looks good. You know, it's hard to know if it's perfect, but we certainly got our two full periods in there. Looks like it probably has a low around 22 and a high around 36. So I think that we're all set. I think that's a good looking graph. All right. Let's take a look at letter C. Letter C says tanker boats cannot be in the bay when the depth of water is less or equal to 25 feet. Should really say less than. Set up an inequality and solve it graphically to determine all points in time t on the interval 0 to 24 when tankers cannot be in the bay. Round all times to the nearest tenth of an hour. All right. Well, what I'd like you to do is first write down the inequality. See if you can do that. Okay. Well, what we want to do is we want to solve the following inequality. We want to have 7 times the cosine of 2 pi divided by 12t plus 29. We want that less than or equal to 25, right? This is the depth of the water, and we want to know when it's less than or equal to 25 feet, okay? Now, how are we going to do that, though, graphically? Well, let's make our TI-84 plus big again. Let's go back into y equals. And in y2, let's just put in y2 equals 25. Okay? So, put that in. We don't have to do anything with the graph. And now let's hit graph. Okay, I'm going to throw that on my graph, and I'm going to throw it on in red. Okay. For me, it would be right about there. And since I now have a second graph on here, I'm going to label it y equals 25. And really what I need to know now is I need to know these intersection points. All right, let's do one of those together and then have you do the other ones on your own. Okay, let's find the one most to the left. Okay, so reminder about how to find intersection points. Let's go to the calculate menu and let's choose the option for intersect. Notice the first question it asks me is first curve. Since there's only 2 curves, I can hit enter. Then it says second curve. I hit enter, right? And then it says guess. So I'm going to bring my cursor over so that it's as close as I can get it to that leftmost intersection point. So once it's really close to that left intersection point, that's when you hit enter. So let's do that now. Okay. Now, of course, the y value is 25. That's kind of, yeah, of course. All right. But the x value is what I care about, and I need it to the nearest tenth, and that ends up being 4.2. Okay. So what I'd like you to do is pause the video now and use your calculator to find the other 3 intersection points. All right. Well, this one was at 7.8. This one was at 16.2. And this one was at 19.8. All right. So we can now write a final answer. We want to know all the times when when tankers can't be in the bay. Well, they can't be in the bay for any time between 4.2 and 7.8 hours because the depth is too low. And they also can't be in the bay for any times between 16.2 hours and 19.8 hours. And that's it. Right? That's when they can't be in there. All right, pause the video now and write down anything you need to. Okay, I'm going to clear out the text. All right. So let's do this. Let's let that TI-84 go away for right now. All right, and let's take a look at the next problem. Next sheet, backside of the sheet. Exercise 2, the height of a yo-yo. Because I know that when we're playing with a yo-yo, when I'm playing with a yo-yo, I'm thinking about trigonometry. Now in this case, it says the height of a yo-yo above the ground can be well modeled using the equation h equals 1.75 cosine pi times t plus 2.25, where h, always know what your variables represent, h represents the height of the yo-yo, so h is the height, no great surprise, in feet above the ground, and t represents the time in seconds since the yo-yo was first dropped from its maximum height. That's why we're using a cosine again, because it starts at its maximum. Letter A says determine the maximum and minimum heights that the yo-yo reaches above the ground. Show the calculations that lead to your answers. All right, well, think about that. Pause the video now and see if you can figure out the maximum and the minimum heights that the yo-yo reaches. Okay, well, this is really just a question about range, right? It's just a range question. So h min, as always, can be found by taking the midline value, 2.25, and subtracting the amplitude, 1.75. And we find that it comes 0.5 feet, half a foot, at its minimum. At its maximum, right, that's going to be the midline, plus 1.75 feet, which is going to be 4 feet. Right, so that's just a midline, amplitude, min-max problem. Now letter B, how much time does it take for the yo-yo to return to the maximum height for the first time? In other words, if we were graphing this thing, right, we got the height versus time. It starts off here at 4 feet, it drops down to a half a foot, right, and then it comes back up to 4 feet. We want to know this time. Pause the video now and think about this a little bit. All right, well, what they're asking for is the period, right? That's really what we want here, the period. Now, what do we know? Well, we don't know the period, but we do know the frequency is pi, okay? And we know the frequency times the period is equal to 2 pi, so I can say pi times the period is 2 pi, and then surely, if I divide both sides by pi, the period is 2. Now, wait a second, how much time? 2 what? Ah, there's my time. 2 seconds. 1001, 1002, 1001, 1002. 2 seconds to get that yo-yo down and back up. All right, pause the video now, write down anything you need to. Okay, I'm going to clear this out and change maybe over to blue. I'm tired of the red. Ferris wheel. All right, a Ferris wheel is constructed such that a person gets on the wheel at its lowest point, 5 feet above the ground, and reaches its highest point at 130 feet above the ground. Okay. The amount of time it takes to complete one full rotation is equal to 8 minutes. Cool. A person's vertical position, 8 minutes. That's interesting and problematic. A person's vertical position, y, can be modeled as a function of time in minutes since they boarded t by the equation y equals a cosine bt plus c. Sketch a graph of the person's vertical position for one cycle, then determine the values of a, b, and c. Show the work needed to arrive at your answers. All right, well, this is very similar to problem A with a little bit of a wrinkle. So what I'd like you to do is pause the video now, try to draw the sketch, and determine the values of a, b, and c. Go ahead and do that now. All right, let's go through it. Well, it says at t equals 0, the person boards the Ferris wheel 5 feet above the ground. That's right here, 5 feet above the ground. All right, and then reaches its highest point at 130 feet above the ground. Okay, so the highest point maybe somewhere out here. Then it's got to come back and return to 5 feet above the ground. How long does it take to do that? It takes 8 minutes, right? So the graph must look something like this. Now, not that it matters that much, but we can note this point is 4, 130. It didn't ask us to do that, but we can because of the symmetric nature of this graph. All right, so we now have to figure out the values of A, B, and C. As always, I like to figure out the value of C first when possible, because C is simply the average of my max and my min values. Now, this doesn't turn out to be the nicest value on earth, but hey, this is Algebra 2. We can deal with decimals and fractions, so C is 67.5. Now, for a minute, I'm gonna take a look at this A. There's something a little bit tricky about the A. So the first thing I'm going to do is actually figure out the amplitude, which is the absolute value of A. Now, again, when I do that, I tend to do the maximum height minus the minimum height divided by 2. Boy, I tell you, this problem is all sorts of messed up. Anyway, that's going to be 125 divided by 2, and that's equal to 62.5. Again, not that nice. But that's not actually the value of A, right? A is actually negative 62.5. And the reason it's negative is because cosine started on this graph at its minimum. All right. In other words, had it started up here and gone like this, if this had been our graph, if this was a really fun ride and we got on at the top, well, then the A would have been 62.5. But because we started a minimum, it has to be negative 62.5. Okay, finally, and this is going to be pretty easy, we have to get the value of B. Well, we know the value of P. It's 8, right? That's this thing. So we know that B times P is equal to 2 pi. So we can say 8 times B is equal to 2 pi, and B is equal to 2 pi divided by 8. It's completely okay to leave your answer like that, but you can also reduce it and tell me B is pi over 4. Either way. That's it. They just asked for A, B, and C, nothing else. All right, pause the video now and write down anything you need to. Okay, let's clear out the text. Do one last problem. Exercise 4. The possible hours of daylight in a given day is a function of the day of the year. Right? You know this, right? I mean, some days have less light, some days have more light, just based on what day of the year it is. In Poughkeepsie, New York, the minimum hours of daylight occurring on the winter solstice is equal to 9 hours. And the maximum hours of daylight occurring on the summer solstice is 15 hours. If the hours of daylight can be modeled using a sinusoidal equation, what is the equation's amplitude? Pause the video now and think about this. All right, this one should be a piece of cake after all of this, right? I don't care exactly what the graph looks like. These are my daylight hours. This is the day of the year, right? Our maximum is 15. Our minimum is 9. Our amplitude can always be found by taking the max, subtracting the minimum, and dividing by 2. So we'll get an amplitude of 3. All right, that's it. Amplitude is always half of that distance. Pause the video now. Write down anything you need to. All right, let me clear out the text, and let's wrap it up. So many periodic phenomena that repeat themselves, can be modeled with sine and cosine curves. I know we concentrated on cosine here. It's often the more useful one in terms of modeling things, although in electrical engineering and many other wave phenomenons, it's primarily sine that gets used. Either way doesn't matter too much. They're essentially the identical function, remember, just being a horizontal shift difference from each other. So play around with the homework. I think you'll probably enjoy these. These tend to be fairly easy for students. And just remember what all of those different parameters represent on the graph. Okay, thank you for joining me for another Common Core Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.